anytime you have an application problem or you have a graph, a good strategy to start with is just to figure out what are your points, like what are the labels on your coordinates. So on the x-axis here I have in minutes driving time, and on the y-axis I have in miles. So every point is going to be minutes, comma, miles. That way when you're reading through the story problem, you can tell if the number they're handing you is an x or a y value. Okay, the other thing that stands out in the story problem is that this situation is a linear function. And as soon as you see that something is a linear function, fancy word linear, line, linear, it's a line. So I know that I can represent this line with y equals mx plus b. So I need to figure out what is the equation of the line. The other temptation is when you're reading through the problem is to really focus on the question being asked. But honestly, you're gonna set the question being asked off to the side because you can't answer the question until you create the equation. So if I want to write the equation of a line every single time, like what do you need? Like going into the problem just before I even read it, like what's a prediction of what they've got to hand me if I'm going to write the equation of a line? You just think. What were we given in that last one? X and Y. They gave me a point, right? They gave me not just 1 point, but they gave me 2 points. So before I even read it, I know somewhere in here has got to be 2 points. And my points are minutes, comma, miles. All right, so I go through, Garan is driving to Miami. Suppose that the distance to his destination in miles is a linear function of his total driving time in minutes. Okay, in other words, I can write y equals mx plus b. Goran has 68 miles to his destination after 36 minutes. See how that goes together? And if I make a point, I know which number should go first because minutes is on the x-axis and miles is on the y-axis. So if I do minutes, comma, miles, this is 36, comma, 68. All right, so they just handed me a point. I continue reading and it says, and he has 50 miles to his destination after 60 minutes. So again, if I make a point with minutes, comma, miles, it's going to be 60, comma, 50. Now that I have 2 points, I can write the equation of a line. And to write the equation of a line, I'm going to need an m and a b. So we could go after the slope first. So if I want to find my slope, I want to subtract my y's over subtracting the x's. So I'm going to either do 68 minus 50 over 36 minus 60, or I'm going to do 50 minus 68 over 60 minus 36. Okay, I went with y minus y, 68 minus 50 over 36 minus 60. When I do that subtraction, I have 18 over negative 24. Both of these numbers can be divided by 6. So 18 divided by 6 is 3, negative 24 divided by 6 is 4. So I've simplified my fraction. Now that I have m, I need to find my b value. We're going to go into our basic equation, y equals mx plus b, and replace the y, the m, and the x, and then we'll be able to find b. So negative 3/4 is going to go in for the slope, and I have 2 options for my x and y. I can use 36/68 or 60/50. So for no particular reason, I went with 60 and 50 rather than the 36/68. When I multiply fractions, I multiply across. Maybe consider this technique. When you're multiplying by a fraction, hopefully it makes sense to you that when a number is in the numerator, that's multiplication. And when a number is in the denominator, that's division. So I could do 3 times 60 over 4 times 1, it's fine. But another way to think of it is, since 4 is in the bottom, I'm gonna be dividing the 60 by 4. And since 3 is in the top, I'm gonna be multiplying by the 3. So 60 divided by 4 is 15, because half of 60 is 30, and then half of that is 15. So 60 divided by 4 is 15, and then 15 times -3 is -45. Okay, so either way you want to go about that, I end up with -45, add over the 45, and I get 95 for my B. So now that I have my M and I have my B, I have everything I need to write the equation. I'm gonna replace the M with -3/4 and the B with 95. So I have my equation, and finally, I'm gonna return to the question that was being asked. At the very end, it says, given this information, how many miles will he have to his destination after 78 minutes? And keep in mind that we know from the graph that minutes, it was minutes comma miles. So they just handed me the X value, and they're asking me to find the Y value. So I'm gonna go in and replace the X there with 78. In this particular one, it's not going to be a whole number or an integer. If you do 78 divided by 4, you get a decimal. So you're either gonna go 3 times 78 over 4 times 1, divide the top answer by 4, or you can do 78 divided by 4 times 3. However you decide to do that, you get -58.5. And I still have plus 95, so my final answer there is 36.5 miles. Okay, so step 1, just a very quick recap. Step 1 is look at your graph and see what the labels are on the X and the Y. So I found out it was minutes comma miles. Then I read through to find 2 points, minutes comma miles, minutes comma miles. Now that I have 2 points, I subtract the Y's over the X's to find the slope. Then we replace the slope and the X and the Y with one of the points to find B. Now I have everything I need to write my equation. I can finally answer the question by substituting in whatever, just pay attention to the label. This was minutes, so I knew they handed me the X, and I plugged in X.